chaos, all good things must come to an end. I'm now here to present Ugo Bruzzo for the closing of this meeting. Ugo, please go ahead.
Thank you. So we had the idea to close this meeting to celebrate Claudio's birthday and his career and achievements, talking about his contributions to history and philosophy of science, mathematics in particular, and what he did in connection with mathematics and literature. I should say that actually, so this is a joint contribution with Pino and myself. And Pino is a specialist in the history and epistemology of physics. I am not. Actually, I learned something collaborating in some way with Pino, and also during innumerable dinners. I mean, dinners with Claudio have been already mentioned several times in this conference. As you can understand, this means something.
Quite and, momentous.
Sorry?
Momentous dinner.
Yeah, and during these dinners, at least when the alcohol contents of our blood was not too high, I heard and also somehow participated in a lot of conversations about these subjects, and so then I thought I could help Pino. So we could have this joint final contribution, let's say. Actually, I also prepared slides, more or less. I will be reading the slides, and some sentences will be original quotations from Claudio's work. They will be highlighted in blue to make that clear. And so the idea is that three threads appear in his work, closely intertwined inside a common framework and a well-defined project. Pino already mentioned this, to bring humanistic culture and science back together. And these three threads, we believe, are history of mathematical thinking, philosophy of mathematics and science, and the interactions between mathematics and literature. And then the idea is to examine one by one these three themes in some detail. Sorry, yeah. So the first is about the history of mathematical thinking, in particular in the 19th century. Actually, mathematics of the 19th century, so-called long century, where the roots of our modernity lie, is not just a dusty pile made up of the results of a long dead science. That mathematics, especially that coming from the second half of the century, still lives in the inheritance it left us, a rich legacy of problems to be solved, knots to untie, conceptual connections to be explored. And here we are just citing a few examples. Already in Riemann, there are speculations about the relations between the geometry of space-time and the physics at the microscopic scale. We may cite the Poincaré's work on the relation between analysis and topology, the nonlinear dynamic of systems. The theory of the continuous groups as strongly developed in that period by Sophus Lee, the investigation by Gauss, Riemann, Dedekind, and Hilbert on number theory. And indeed, the book, A Pyramid of Problems, focalizing on geometry, especially on its development in the second half of the 19th century, describes three different research threads: projective geometry, non-Euclidean geometries, analysis situs, namely modern terminology, algebraic topology, continuous transformation groups, and these are tightly intertwined and have correspondences in all branches of mathematics, giving rise to a thick network of connections and to a productive interchange of ideas and methods. And again, we can cite a few examples. Analytical mechanics uses tools from differential geometry. Real and complex analysis takes advantage of topological techniques. Transformation groups are involved in the development of a projective geometry, which on the other hand interacts with algebra. Cantor's set theory poses difficult problems to analysis and topology. For instance, the problem of the definition of dimension. And the theory of Riemann surfaces, going back to Riemann's inaugural dissertation, which gathers disparate research lines and sets new research horizons. Historical narrations are never neutral. Paraphrasing Kant, the history of science without philosophy is blind, and the philosophy of science without a history of science is empty. Thus, the investigation on the history of mathematics are tightly entwined with the contributions to the philosophy of science, which is the second thread we want to talk about. Here, the viewpoint is that the historical reconstructions are not description of linear processes where knowledge increases by adding ever new propositions, but are consequences of a specific understanding of the nature of mathematics. The traditional vision, where the work of the mathematician only consists in a more or less formal, the more or less formal proofs of theorems, starting from axioms and definitions, is utterly inadequate to describe a much more complex reality, where conjectures, analogies, heuristic reasonings play a fundamental role. As Giancarlo Rota remarked, to confuse mathematics with the axiomatic methods in which it is presented in most treatises is like confusing Vivaldi's music with the counterpoint techniques of the Baroque period. Mathematical knowledge is more than the outcome of a linear evolution. It is the delicate result of a complex conceptual stratifications, of contaminations induced by sculptural interchanges. It is the uncertain fruit of the transformations of ideas that have been thought of again and again in the history of mankind, in different places and times, that were born and set down in the ever-changing sequence of memories and oblivions. These are, as I was saying, words by Claudio. They were in Italian, so then I have translated them into English. Here, we cannot but hear the echo of the words of such great masters as Michel Foucault and Gaston Bachelard. In particular, the latter's concept of epistemological rupture resonates with the idea that mathematical knowledge does not grow by accumulation, but rather undergoes a steady process of restructuring. So the resulting image of mathematics is diametrically different from the one coming from the Platonic tradition. The idea of a geometer, philosopher, a decipherer of the truth must be replaced by a much humbler notion of the mathematician as an artisan, an inventor of clever but temporary solutions, an apprentice of truth, and an unassuming maker of models, since mathematics doesn't study objects, but rather the relations among them. Citing Henri Poincaré, mathematics is the art to give the same name to different things. Joining the relational viewpoint, one reaches the conclusion that for a scientist who is not a mathematician, a physicist or a biologist, for instance, the important things in mathematics are not the results, but rather the definitions. Definitions tell us what is, for instance, a conical section, fractal, a group, precise statements that isolate these concepts among all the possible ones in the infinite network of relations. This is what is useful in the applications. Paul Valéry, the poet of imaginative rigor, wrote in his cahier that mathematics is the realm of arbitrariness. These words may help us to understand the importance of definitions. Definitions are arbitrary, albeit they must be rigorous. That is, they must comply with the logical constraints set by the formal system where they belong. So the arbitrariness is not anarchy. There exists a dialectic connection between definition and theorems. Only good definitions originate good theorem, and good theorems generate good definitions. Unfortunately, this interdependence is almost always omitted from the mathematical textbooks, which present definition as if they were born, like Athena, from Zeus' head, already fully horned. And now, this takes us to the last topic I want to mention, the interactions between mathematics and literature. And here we start with an anecdote told to me by Pino. So now it's Pino talking. Many important moments of my friendship with Claudia were marked, again, you see, by scrumptious dinners and unforgettable wines. And the conversation in many of those dinners was about two great passions of his, Musil and Valéry. This gave me this idea. In the mid-90s, I was teaching in a high school in Rapallo, and I had the idea to organize a seminar whose topic was somehow untypical for those times: mathematics and literature, comparing knowledges and languages. I still remember the incipit of Claudio's talk, very much in his style. Nobody denies that mathematics and literature are different things, like bread and salami are. But nobody can deny that bread and salami go together very well. Actually, the original wasn't bread and salami, it was fave e salame. But in translating, and also not only translating into English, but for a wider public, I thought that perhaps people away from Liguria don't know that we very much appreciate fava beans with salami. One of the best food in the world, according to me. Anyway, it was a great talk, Pino says, that teachers and students alike appreciated very much. So, what about mathematics and literature? In spite of its proverbial abstruseness, or perhaps just due to it, mathematics over the last, say, 150 years has exercised a strong, albeit sometimes veiled, charm on the artists, musicians, writers, and philosophers who were looking at its prodigious richness from the outside. Mathematical ideas and structures, such as transfinite numbers or non-Euclidean geometries, metaphors based on concepts from algebra or logic, are the common denominator of poets and writers who are otherwise completely unrelated. One should stress that in most cases, these inflows of mathematical concepts are not systematically metabolized, nor are they developed according to some didactic or popularizing program. As André Veil remarked in his short essay, De la métaphysique aux mathématiques, nothing is more productive, as all mathematicians know, that those vague analogies, those obscure reflections that move from one theory to another, those stealthy caresses, those inexplicable discrepancies. Nothing gives the researcher a greater pleasure. Perhaps mathematics and literature do not aim to truth, but rather to beauty. At least the search for beauty, certain form of beauty, is what they most secretly have in common. As Wisława Szymborska writes, I can easily imagine an anthology of the most beautiful pieces of world poetry, making room for Pythagoras' theorem. And why not? It sets off the sparks that are the marks of great poetry. Its form is paired beautifully to only the most necessary words, and it has a grace with which not even every poet has been blessed. So this is what we wanted to say, and all talks in such a situation must end with the birthdays, so I'm not the first, but at least in this conference, I am the last, perhaps, to wish you, Claudio, a very happy birthday and continuation of your great activity. Thank you.
Thank you, Ugo.
Thank you very much. I'm particularly touched by this final talk. Well, and touched is the right word in this case, and it was quite a surprise to me. I mean, I didn't expect, and so thank you, Ugo, and thank you, Pino, for this. So, but thank you to everybody in this conference. As usual, I learned a lot. I say as usual because, well, I learned a lot from everybody of you, and this is, in some sense, is my secret to learn from different people, different things, and so I'm very much in debt with every one of you, and I must also apologize with you, and because I know that I'm not sometimes I'm not a perfect collaborator, in the sense that I'm always late with different projects and so on, but I'm always doing my best in some sense. And so this is true not just for the people which are here in this moment, and not even for all participants in this conference, collaborators or friends or not, but more generally for the many people that interacted with me. Say for the I've been interacting with me, say for the last 40 years, more or less. So a great part of my life. Of course, I should mention, I think this is the right place to do also the what I think of my teachers. There are not so many in some sense. Ugo is one of them, and then there are the teachers in my English experience during my PhD at Warwick University in the late 80s, and Jim Mills and Nigel Hitchin. And I didn't interact much with Hitchin, but his influence on my work, as especially in mathematics, has been enormous. And the last name I would like to mention is the name of Giulio Giorello. And well, unfortunately, he's not present at this conference, and because he died 2 years ago, but he he was my my teacher, my master as well, in philosophy and in life. So thank you, my warmest thanks to everybody of us. Thank you for this wonderful conference. It was a great present.
Thank you very much, Claudio, for your kind words. And thanks everybody for showing up during this week. I propose a special round of applause for Valeriano and Ugo Bruzzo.
Yes, of course, I forgot, because I was of course, thank you to Valeriano and Ugo also for the organization. Well, I said that it was a fantastic gift for my 16th birthday, but
you're welcome.
Yeah, so thanks Ugo and Valeriano for bringing us together this week.
Valeriano did most of the work.
Thank you all for participating.
I, for one, am very happy and honored to be part of this celebration of Claudio's work. And this is this phrase in the end that nobody denies that mathematics and literature are different things, but everybody should agree that they go well together. I think this is a great lesson for everyone involved. So thank you very much, Claudio, and thank you very much, everyone. It was really an honor and a pleasure to be part of this group.
And as always, if I can say just two words, very much in my style, the important thing is to have fun in any case.
Absolutely.
Not to be too serious.
Yeah.